Next up we have Dr. Francis Chiew from the CSIRO who'll be talking to us about WIRADA, a SWOT analysis. Dr. Francis Chiew is a science leader and leads CSIRO's hydroclimate and hydrological modelling group. Francis has a long history of leading climate water research and working with the industry in Australia and overseas, including Murray-Darling Basin Sustainable Yields and South Eastern Australian Climate Initiative. Francis leads CSIRO's research capability delivering hydrological modelling projects, including WIRADA. Thanks very much, Francis, for joining us today.
Thanks, Dan. Okay, thanks, Dan, for that introduction, and thanks for the opportunity to make this presentation here. So what I've done was put together a couple of slides on WIRADA, and I'll take you to the journey through WIRADA, which is really an alliance, a research alliance between the Bureau of Meteorology and CSIRO, talk about some of the products we have delivered, the successes, achievements, and also the process that actually led to some of these successes and where we go from here. So by means of introduction, that's what WIRADA is. It is a short for an acronym for Water Information Research and Development Alliance. It has been going on for about 8 to 10 years now and still ongoing at a smaller scale over the past 2 or 3 years. So what it does is brings together CSIRO's leading expertise in water and information services, and also combined with the Bureau's expertise and their role in doing operational hydrological analysis and prediction. So you would have seen a lot of the water information products from the Bureau, which started about 10 years ago, and I'm sure many of you are using quite a lot of stuff coming out from the Bureau Med's water information product. So what I'll be talking to is mainly the research that helps lay some of the foundation. So very apt presentation for today's talk, which is really about a combination of translating the research to the Bureau's operational products. But before I delved into WIRADA per se, I think it's good to share a couple of slides just on some of the challenges and how some of these things came about here. So by means of a contextual thing, I think it's worthwhile recognizing that we in Australia are the driest inhabited continent, but we actually have the highest per capita water use. Okay, it's not because all of us are guzzling water and using water freely. It's because we actually use water to grow food and we export agriculture outside. So we're exporting water to other countries also. So we have to actually manage our water resources really well. Another interesting observation is coming from a hydrology background. Our hydrology is different, and so that presents significant challenges and opportunities. So our runoff coefficient is low, so less our rainfall becomes runoff, so we got to manage that accordingly. We have a very high inter-annual variability. In fact, our streams are in fact twice more variable than streams elsewhere in the world. If you focus at the plot at the top, so the red colors shows areas with high inter-annual variability. So streams in Australia, streams in South Africa are amongst the most variable in the world. So that's why we got to build big storages just to get the same reliability of water supply. Okay, but the same variability that we are seeing is also helping with the predictability in our systems. So our systems have reasonable predictability, shown again by the crosses at the top. So across the Pacific, in South America and in Australia, we tend to have a stronger correlation between El Nino, Southern Oscillation, you heard about that, and rainfall and stream flow. So we in fact exploit this. And I'll talk to you a bit later on about how the Bureau of Meteorology exploits these to help forecast rainfall and help forecast several months in advance to help manage our very variable system. And the last aspect at the bottom relates to the climate change impact that I'm sure many of you are aware of. So changes in rainfall are amplified in stream flow. That amplification is also larger here in Australia than elsewhere in the world. So we've got more significant challenges. In fact, that number is about 2 to 3. So one of the messages that you can get from here is, as a rule of thumb, where you see about 10% change in rainfall might happen, well, that would translate to about 20 to 30% change in stream flow on average in Australia. Okay, so what what has happened in the recent past. So the plots on the left-hand side shows the rainfall and runoff anomaly in the annual time series in Victoria. So you can see the top plot, we were very dry over the periods. I'm sure we will have to live in a rock if we haven't heard of the Millennium Drought over 1997 and 2009. So like I said, impact you see in the rainfall is amplified in the stream flow. So very dry conditions there, and projections, which is part of another presentation we're going to hear about this, is actually showing that in the southern parts of Australia, we're not sure elsewhere, but certainly in the southern parts of Australia, we are projecting likely dry conditions into the future. So all these things have accelerated some of the water reforms that's happening across Australia. So you hear about the Murray-Darling Basin Plan, which is still ongoing. And in fact, it was towards the end of the Millennium Drought where CSIRO was commissioned to do a whole sustainable use study. And following that, the Bureau of Meteorology Water Information was established, a program about $500 million over 10 years and continuing to be ongoing after that. And as part of that, spurned this WIRADA alliance, the alliance between the Bureau of Meteorology and CSIRO to do research, mission-oriented research that translates into operational products that the Bureau, to help the Bureau deliver the water information products. So that's the genesis, I suppose, of WIRADA. So we have taken that opportunity, spent about $60, $70 million over 8 years, 27 research projects. We had about 250 person years of working through these and delivering almost 20 operational products at the Bureau of Meteorology. So I'll share with you this slide here, which is not all WIRADA, but a whole range of products in the Bureau's water information website that you can go to. For those of you who were here, I think it might be last year or year before last, Rob Argent, who leads the Bureau's Water Division, would have presented about the Bureau's water information product. Anyway, you can see all these in the Bureau's website, but just by means of example, a lot of that are based on, in some aspects anyway, from stuff which came out from the WIRADA research. So as Rob Argent would say, the Bureau is providing a lot of data, but it's not just the data, but it's a process about how do you provide the data, ranging all the way to the modeling, the analysis, reporting, and the forecasting. So insight into the data to help manage our variable water systems. So right at the outset, we knew that science is important. It's no point just churning out numbers. So it's very important to provide the robust evidence base and knowledge science to guide some of this data. So we have, as a part of WIRADA, we have published over 100 journal papers in the highest international journals, and also working with a whole range of international and overseas as well as Australian collaborators. So by means of example, I've flagged some of the research papers that has been in water resources research, just to show some means of example. A wide-ranging, diverse field from helping co-manage surface groundwater resource, forecasting catchment rainfall from the weather forecast that comes from the Bureau, robust estimation of evaporation, reducing hydrological modeling errors, and you heard a bit about satellite data. So using satellite data to better understand long-term soil, vegetation, moisture, model averaging using the best of different models to deliver the best possible stream flow forecast, prediction in runoff in ungauged basins, and a whole series of other papers, all of which are in the leading journals of water internationally in water resources research. So this is just by means of example, some of the range of research, robust research that underpins some of these water information products that you see. Now, I think I need to highlight this important aspect too. It's not just about knowledge and research per se. We're dealing with a lot of data and more data over time with digital technologies and so on. So part of WIRADA was also about developing standards, and standards not only used in Australia, but also guiding international staff from the Water Informatics Group in CSIRO and in the Bureau of Meteorology. So by means of example, it's about 20 million data transfer files across Australia to underpin some of the water information product that you see in the Bureau of Meteorology. Now, what I think is important also are the foundation products. So right at the outset, it's about putting better rainfall data. So the gridded rainfall data that some of you use through the Bureau's website also come from some of this radar research. So putting the best of observations as well as satellite pictures of and radar pictures of rainfall, as well as developing the evaporation products. So another big outcome is the 30 meters DEM, digital elevation mapping across Australia, which I'm sure underpin many of the modeling work that you might do, as well as a geofabric system that shows connectivity between river networks that are used by us as well as the Bureau to furnish some of these water information type aspects. But I might just pause and just talk about 2 or 3 key products from the WIRADA area that we are still continuing research on in the AURA, hydrological modeling world, and in the seasonal and 7-day streamflow forecasting world. I think, I shared with you some of the research that I showed you earlier on with the research papers and so on. If that was all we were doing, the research, transferring knowledge, and putting the data out there, I think we could have done a lot of these in half the time of WIRADA. But I think the challenge is working collaboratively in partnership and having a clear goal about how you translate these to operational products. It's not an easy task. I mean, coming from a research background and then seeing the work that we have done with the Bureau, that's incredible. The kind of meticulous things that you've got to do to ensure you can translate something to operations. Often it's not really based on possibly even the best research, but the best research that can consistently deliver things in a consistent, defensible, and repeatable way. And that's what operational systems are about in the Bureau, as well as similar agencies worldwide. So that's a challenge. I mean, to do research is just one part of the story. To translate that to operations, which is really the theme of this talk here, it's double the effort, in my opinion. Okay, so one of the stuff that you can see in the Bureau's website is this landscape water modeling. So what's underpinning this is the Australian Water Resource Assessment model. And really, the idea here is to build models similar to the models that you might have built, hydrological models, conception models, rainfall runoff models. So that's the modeling world that I showed here. But the art of that is building the models as well as using the best possible data sets that you can get. So that includes the satellite observations, mainly your soil moisture, vegetation, and evapotranspiration, how you ingest this data and put it together with the hydrological models to get the robust predictions. Now, it's also important, all the satellite data does is give you pictures of light, I suppose, but the ground truthing with ground observations of measurements, which we use to ground truth the satellite data, as well as to calibrate and parameterize and build the models. So if you think about this, it's really the model data fusion of the best of 3 worlds. You get satellite data which have a complete coverage, but historical. You got observed data which we believe is the truth, but only at point locations. And then you got models which clearly can build an understanding and do everything, but it's just a model that can do everything as well as predict into the future. So really putting all this information to furnish what you have now through the Bureau, daily water fluxes and stores underpinned by AURA. Now, AURA is also used for a whole host of other applications which you can find out more from the websites. Another product that the Bureau has furnished is this National Seasonal Streamflow Forecasting Service. So that's again by means of example, prior to the water information scheme, we didn't have this, but now you got now pictures of what might happen in the next 3 months. And the product which came out about 5 to 10 years ago was really around providing forecasts 3 months in advance, but listening to the customers, we now also provide forecasts in an ensemble way over the next 3 months in monthly totals. I've been given a run-up by Dan here. Another product that we have here is a continuous 7-day streamflow forecast, putting together Bureau forecast, so it's modeling, and then doing a whole series of stuff to provide 7-day streamflow forecasts in advance also. Okay, and to Here's just some examples of some of the things that the seasonal forecasting products as well as the Aura work has actually been out there. But these slides are out there, and we're sharing these slides anyway, so you can have a look at a lot of this stuff. But then can I just flip through some of these slides, which were actually put together by Rob Argent and Warwick McDonald, CSIRO, around there are a lot of things that needs to be done to ensure successes of things like this. So it's really around governance, operations, engagement, the whole management, direction and science. I think a lot of success is done through strong engagement, high quality research, which I've spoken earlier on about, but it's very important to stress again, it's not just about doing the science, not only about high quality science, but the work that actually requires and a background knowledge that you need to drive to make sure you're translating the research, the whole research to operations translation. Very important there, and having a clear science plan to get you there. Equally important is this governance, accountability and management. So making sure you plan, you say what you're going to do, and you end up delivering these products. Because without that, we wouldn't have the mandate to continue on doing more of this work as well as products into the future. I'll just finish off with one last slide here. So I hope it's a very quick journey through some aspects of WIRADA. So I think you've heard around some of the scientific and technological innovation and how we translated these into operational products for the water and related industries. Very important to note that the success has been achieved through strong partnership, good governance, high quality science, and clear direction of the operational outcomes. And the third and fourth points is what we are currently building on staff in WIRADA success to enhance and develop new products. And you can read on the screen there some of the opportunities that we see in this space. But equally important is also more of our work now partnering with government and industry, because we believe that through that we can actually maximize the use and outcomes of using the water information products, both from WIRADA and what's delivered by the Bureau of Meteorology. Thank you, Ted.